Okay, students, for 4A4B4C again, a very good morning to all of you. So I hope you're all doing fine. Semua sihat ke dekat sana? Semua sudah breakfast? Ada yang sudah pergi vaksin ke? Okay, very good. Okay, so I guess you're all ready to begin with the lesson. Tak apa, nanti yang lain masuk kita add saja dia. Okay, so you may see it in a more, okay, first dose done. Okay, so far you're doing good with the vaccine. Any side effect? I hope you're doing fine with them. No dizzy at all means your tak ada side effect. Okay, very good means your body reaction is good. Badan kamu kuat lah. Okay, no fever sikit, ifong, itu normal sign. It's a reaction of your body immunity towards the vaccine. So I hope nothing bad happen to you lah. Harap semuanya okay, sihat macam biasa. Kalau tak ada apa, mudah-mudahan kita boleh kembali ke sekolah seperti biasa. Sedikit masa lagi. Okay. Alright, so if you are ready to go, we have begin with the first part of this chapter, wave with first content standard 5.1, fundamentals of wave. Okay. So I have discussed to you what is wave refers to. Students, what is wave refers to? Apa itu wave? Boys and girls, what do you understand by the words wave? Wave itu apa?
Something like the W.
Yeah, come again.
Something like the W.
Something like the W. Can you write that answer in the exam? Boleh tulis macam tu tak dalam exam?
No.
Give a proper definition. What is wave? Can you see my screen?
Yes.
The answer is there. Okay. So wave is produced. So can you read from the slide?
Yes.
When they ask you to write a definition of wave, so you should write wave is produced by oscillating or vibrating system. Okay, the keyword is oscillating or vibrating system. Produced by oscillating or vibrating system. Okay, so this is the example of sources which can produce wave. Okay, the tuning fork will produce sound wave when it is vibrate, when you knock it with something. And then the second diagram, this is what we call as this is ripple tank. The ripple tank produce water wave when we turn on the vibrator. Okay, and then the third diagram, this is what we call as a slinky spring. It can produce both longitudinal and transverse wave. Today we are going to talk about what is longitudinal, what is transverse wave. Okay, students, and we also have learned when wave propagate, when they move from the point producing the wave outwards, they transfer energy. Okay, wave transfer energy from one point to another. Last time kita sudah tengok contoh ini, how the candle vibrates. Okay, the flame of the candle vibrates when it plays in front of a speaker, when the speaker is turned on. So the air molecule in front of the speaker vibrates, so it transfers energy. Finally, the energy reaches the candle flame and it will causes the flame to be moving. Or you can see the flame is finally vibrating since it is received energy. Okay, and we also have looked, there are two types of wave. So I hope you have completed your exercises in your workbook on page 1, 2, 3. Ada buat tak latihan? Cuba buka buku kerja page 1, 2, 3. I ask you to complete number 1 on type of wave. Okay, yes, last time we have discussed there are two types of wave. The first type is called as progressive wave. Okay, progressive waves refers to a wave where the profile is changes with time. Okay, profile means the looks of the wave changes with time. Okay, and it is propagate outwards in all direction, as you can see from the diagram above here. At the center is the sources producing the wave, so it propagates outwards in all direction. Okay, so you can write the definition for progressive wave. The profile of wave changes with time. Okay, and then second we have, can you give example of progressive wave? Students, for progressive wave, we have two examples. First is transverse wave and second is longitudinal wave. So you can write this in the two boxes down there. Transverse wave and longitudinal wave. Okay, these two are both called as progressive wave. While for the second type, we have, ini cikgu ulang semula saja sedikit apa yang kita belajar sebelum ini. Second type, we have stationary wave. Okay, stationary wave refers to a wave where the profile of the wave does not change with time. So you write the definition that profile of the wave does not change with time, which means this kind of wave, it does not propagate with time. Profile means the appearance of the wave. Okay, you can see the crest, you can see the trough there. Okay. Example of stationary wave, students. Example of stationary wave, you can write there, wave produced by musical instruments. For example, when you plug a guitar, and you can see the guitar here, the string has 2 points, right? If you look at the guitar here, it has 2 points, okay? This is the first end and this is the second end. So when you plug a guitar, a wave is produced from both ends and they will meet at the center where finally the two waves are going to be cancelled off. So finally the string stop vibrating. So that is what we call as a stationary wave. It doesn't propagate with time. Okay, finally it stops vibrating. Same goes when you hit a drum. Bila kamu ketuk drum, okay, when you hit a drum, the surface of the drum vibrating from both ends, okay, and it will meet at with the two waves meet at the center, and it happened that the crest meet with the trough, so it will cancel off, and finally it will stop vibrating. So that is what we call as a stationary wave, where finally the wave stops. Okay, it doesn't propagate with time. I am not referring to the sound produced by this music instrument. I am referring to the wave produced inside the body of the instrument itself. Okay, so I hope you're clear with that, because the sound wave that produced is referred to progressive wave. Bunyi yang dia keluarkan itu adalah progressive wave. But the wave occur in the body of the musical instrument itself is what we call as a stationary wave. Okay, and we also have looked, there are two categories of wave. This one you can complete in B, okay, in the table diagram in B, classes of wave or category of wave. We have mechanical wave. Okay, mechanical wave defined as a wave that require medium to transfer energy from one point to another. So you can write the definition. The first point is the definition for mechanical wave. You can write on the box there. Okay, require a medium to transfer energy from one point to another. If they ask you what is meant by mechanical wave, so it is a wave which require or need a medium to transfer energy from one point to another. And these are the example of mechanical wave. Water wave, okay, the medium is water. Sound wave, the medium is air. Okay, seismic wave is the wave that produced underground, so the medium is at the earth. All right. And then later we have electromagnetic wave. Okay, this is electromagnetic wave. The definition, this kind of wave does not require a medium to propagate from one point to another. Okay, you boleh tuliskan yang ini. Okay, does not require a medium to transfer energy. You can add a bit more there from one point to another. And then second, you can add made up of oscillating electric and magnetic field perpendicular to one and another. Okay, this is the definition or the keyword for electromagnetic wave. Okay. And this is example of electromagnetic wave. We have radio wave, light wave, gamma ray, ultraviolet, X-ray, gamma ray, microwave, cosmic ray, visible light, semua, and so on. Okay, so all these waves consist of magnetic field and electric field which oscillating 90 degree or perpendicular to one and another. Okay. Okay, so today students, we are going to continue with the third learning standard is to compare transverse and longitudinal wave. Okay, this one you can find again in your workbook on page 123, number 2. Okay, exercise number 2. There they ask you to give the difference between transverse and longitudinal wave. So let us first take a look what is transverse and what is longitudinal wave. Okay, so this is what we call as a transverse wave. Okay, so if you look at this simulation, the red arrow shows the direction of vibration of the particle. Okay, while the blue arrow shows the direction of propagation of the wave. So what can you say about these two directions, how they are moving towards one and another? What can you say about the movement of the direction of vibration of particle and the propagation of wave? They are vibrating in the direction perpendicular to one and another, right? You can see that the particle vibrates up and down. Okay, while the direction of propagation is from the left to the right. So they are vibrating perpendicularly towards one and another. Okay, so this is what the definition for transverse wave. And this is another example, shows how we can produce transverse wave when we are moving this slinky spring up and down. Okay, the red dot there shows the particles. It represents the particles of the spring. So you can see that it moves up and down while the spring propagates from the left to the right. And again, they are perpendicular towards one and another. Okay, vibration of particle perpendicular to the direction of propagation of the wave. All right. So students, if they ask you to write the definition for transverse wave, the answer is stated in number 1. Okay, it is a particle. Okay, what is transverse wave? Transverse wave refers to where the particle of the medium vibrate in the direction perpendicular to the direction of propagation of the wave, as stated there. Okay, transverse wave, you can look in your book, page 123. Transverse wave is a wave in which the vibration of particle in the medium is perpendicular. So you write there perpendicular, 90 degree to the direction of propagation of wave. Okay, while again, and this transverse wave is made up of consecutive crest and trough. Consecutive means side by side. Okay, this is the first crest, this is the second crest, and this is the third crest. So do the trough. This is the first trough, second, third, and so on. An example of transverse wave, we have water wave and electromagnetic wave. Okay. And this is the second wave, longitudinal wave. Okay, now you can, what is the difference? Okay, again, the red arrow shows the direction of vibration of the particle, while the blue arrow represents the direction of propagation of the wave. So now what can you say about the movement of these two, blue arrow and red arrow, how they are moving towards one and another? Okay, they are moving in parallel. Okay, the keyword there, I underline the keyword there. Particles of the medium vibrate, okay, in the direction parallel to the direction of propagation of the wave. Again, by using the slinky spring, we also can produce longitudinal wave. Okay, now we move the spring back and forth. Kita gerakkan dia ke depan dan ke belakang. Okay, so the blue dot represent the particles of the spring. So you can see it move to the left and to the right, to back and front. And the direction also moving in the same way, parallel to the blue dot. So this is what longitudinal wave is. It is a wave where the particle of the medium vibrates in the direction parallel to the direction of propagation of the wave. So you write that, parallel or longitudinal wave. So what is example of longitudinal wave? Sound wave. Okay. And for longitudinal wave, you can see it is consists of compression. Compression is the compressed region. Okay, you can see that the wavefront is closer towards one and another. Okay, I show you the simulation again. The spot where is the compression and where is the rarefaction or the stretch region. Okay, you can see that the denser line in this is what we call as the compression region. Okay, where the wavefront is compressed, they are getting closer towards one and another. Okay, and this is the rarefaction. Okay, the rarefaction region where the wavefront is further towards one and another. Okay, rarefaction ini dia compress. Okay, the wave is compressed. So it getting closer. The wavefront is closer towards one and another, while this region where the wave is stretched. So when stretched, it getting further from one and another. So there are two regions for longitudinal wave, compression and rarefaction. Please spell correctly because some student later on dia akan tulis refraction. Salah ya, refraction itu nanti kita belajar. It is the next phenomenon of wave. Ini rarefaction, R-A-R-E-F-S-C-T-I-O-N-S. You can't remember too much. Apa yang tak boleh ingat tu? So far you have to know the definition. What is transverse wave? What is longitudinal wave? So there are two keywords. Direction of propagation of wave and direction of vibration of particle. Ada dua. Okay, vibration of particle and then direction of propagation of wave. Kalau if transverse, it is perpendicular. For longitudinal, it is parallel. Itu saja yang you perlu ingat. The keyword is ini, vibration of particle. Second keyword, direction of propagation of wave. Again, for transverse, they are perpendicular. And for longitudinal, they are parallel towards one and another. And for the example, longitudinal wave, example is sound wave. For transverse wave, example is water wave and electromagnetic wave. Okay, Yifong? Okay, don't worry, take your time to digest with the definition. Okay, that's all with Learning Standard 3 to understand, to compare and contrast transverse wave and longitudinal wave. Okay, students. Okay, now I want you to check, before we go to Learning Standard 4, can we please check on the exercises on page 1 to 4? Can you please turn to page 1 to 4? You can see they are diagram 5.2a and diagram 5.2b there. Okay. In diagram 5.2a, what do we have there? You can see there is a slinky spring, okay, moving up and down, swing to the up and down. And you can see there is an arrow show the direction of wave vibration. Direction of wave vibration itu sama juga, similar to direction of propagation of wave. Okay. And then we have another arrow which is vertical, show the direction of vibration of the particles. Okay. So, and then down there you can also see it is drawn in a line. And A is the crest, while B is the trough of the wave. And then in diagram 5.2b, you can see the slinky spring is now moved forth and back. Okay, you can see the direction of vibration is now parallel to the direction of vibration of the particles. Okay. So for 5.2a down there, you write the example of transverse wave 1, 2, and 3. Okay, can you give 3 example of transverse wave? Cuba bagi contoh example of transverse wave. First, we have transverse wave, sin wave, transverse wave. Sound wave is longitudinal wave. Okay, so UJ sound wave, radio wave, very good. Okay, radio wave itu dia masuk dalam electromagnetic wave. So it is transverse wave. What else? Another 2. Transverse wave, we have light wave, very good Eliana. Light wave also part of electromagnetic wave, so it is transverse wave. Yes, very good sin wave, water wave. So you can write X-ray, you can write gamma ray, you can write infrared wave, microwave, that is all electromagnetic wave, okay, which is categorized under transverse wave. Okay, and how about longitudinal wave? Longitudinal wave, we have sound wave, sin wave. Sound wave is longitudinal wave. Okay, the direction of vibration of particle is parallel to the direction of propagation of the wave. Okay, so I hope you are clear what is example of transverse and what example of longitudinal wave. Okay, so now let's check on number 3. You are asked to give differences between mechanical wave and electromagnetic wave. So let us first go back to our previous slide. Okay, apa beza? What is the difference between mechanical and electromagnetic wave? Okay, you are asked to write 2 difference. So what is the difference, students? Mechanical and electromagnetic. Okay, this is mechanical. So first point you can write, require medium to transfer energy. Okay, from one point to another. Okay, this is the first point you may write. Okay, requires a medium to transfer energy from one point to another. While for electromagnetic wave, you write the other way around. Do not require a medium to transfer energy from one point to another. Okay, it's the opposite. How about the second point? What else can you write about mechanical wave? You can write point number 2 here. Made up of vibrating particles of a medium. Okay. It is made up of, consists of vibrating particles of a medium. Okay, for example here, the water particle is vibrating. Here, okay, the air particle is vibrating. Okay, so it produces sound wave. Here, water wave vibrating, so it produces water wave. Here, okay, it produces, what do we call this? This is a windmill, right? So it produces What wave is produced by windmill? Seismic wave. Okay, seismic underground. So the earth particle is vibrating. So it is produced seismic wave. All right. Okay, while for electromagnetic wave, so the first point you write does not require a medium to transfer energy from one point to another. Okay, this is the second point you can write, made up of or consists of oscillating electric and magnetic field which are perpendicular to one and another. Okay. And then for the example, you can write example of mechanical wave, as you see just now. For mechanical wave, what is the example of mechanical wave? Can you give 3 examples of mechanical wave, students?
Water wave, sound wave.
Sound wave, yes. Then we have water wave and seismic wave, okay, as you can see from this slide. Okay, example of electromagnetic wave, it can be radio wave, it can be light wave, it can be gamma rays, or you can write sound wave, you can write, sorry, this one electromagnetic wave. Okay, for mechanical wave, it is one water wave, sound wave, seismic wave. Okay, again, water wave, sound wave, and seismic wave are example of mechanical waves. Okay, and then for electromagnetic wave, you can write any wave which consists in the electromagnetic wave. For example, light wave, radio wave, gamma ray. Okay. Ada beta wave tak? Ada tak beta wave? Beta itu apa? Beta itu radiation. Okay. It's a ray. So it's a ray. When beta is actually a fast moving electron. Yeah, beta ray. It's a fast moving electron. Okay. Beta ray itu negative particle consists of fast moving electron. So we have a lot of electron moving in a fast motion that assemble as beta ray. All right. Okay, so we are done with that electromagnetic and mechanical wave. So we also have compare transverse wave and longitudinal wave. So are you doing well with transverse and longitudinal wave, students? Can you follow me? For transverse and longitudinal, remember the keyword is vibration of particle. Second, direction of propagation. Okay, for transverse, it is perpendicular. And then for longitudinal, it is parallel. Okay. Okay, then let's check on the next slide. Okay, learning standard 4. Okay, in learning standard 4, each and every one of you must know how to explain the characteristic of wave or the properties of wave according to this aspect. First, what is amplitude? What is period refers to? What is frequency? How to find frequency of a wave? And then what is wavelength, which is represented by lambda, and how to calculate wave speed, represented by V. Amplitude represented by capital A. Period represented by capital T. This is the symbol for period and this is the symbol for frequency. Okay, wavelength is lambda. Again, wave speed is represented by symbol of V. Okay. So let's check. Before that, let us take lambda, L-A-M-B-D-A. That is the name for that sign. Okay, lambda, L-A-M-B-D-A. This one. Okay, we call this as lambda, L-A-M-B-D-A. Okay, lambda. This one symbol is omega. Okay, omega. This one symbol is beta. This one the symbol is alpha. And this one ini gamma. All these are Greek. Okay, Greek name, Greek terms. Okay, because last time most of the scientists, most of the physicists, they come from the Greek, okay, from the Latinian, okay. Then kita ada a lot more we are using in mathematical expression as well, kappa, zeta, and so on. Okay. Okay, then let's check on this first. Okay, you can see now, this is an old clock. Okay, ini classical clock. Okay, you can see that the pendulum swing from A to B and then back to A. Okay, students, when this pendulum swinging from A to B and then went back to A, so we said that the pendulum have done one complete oscillation. Okay, I repeat, from A to B and then went back to A. So we said that this pendulum have done one complete oscillation. Okay, A, B, A, one complete oscillation. Video ini memang tak ada sound So from here, we can understand what is meant by period. Okay, period refers to time taken for one complete oscillation. Let's say before we release the pendulum, okay, so the moment you release, you start your stopwatch. Okay, so from A you start your stopwatch, and then when it come back to A again, you stop your stopwatch. And then let's see the time is 5 seconds, which means 5 seconds is the period. So what is period? Time taken for one complete oscillation. Okay, so that is period. So can you check on page 1 to 5? 1 to 5, see the table there. So you write what is period. Okay, period is time taken for one complete oscillation. Okay, you write there period. And the symbol for period is T, capital T, where the SI unit is in second. Okay, second, the symbol is S. Okay. And then what else we can study from this simulation? So just now you see what period is, time taken for one complete oscillation. Okay, this is example. Okay, how to count the period. Okay, 10 oscillation is 5 seconds. So what is the period here, students? For this example, 10 oscillation is 5 seconds. So what is the period? Okay, any idea what is the period here? Okay, we begin this experiment again. Okay, this hacksaw blade is released from one position and it makes 10 oscillation in 5 seconds. So can you tell me what is the period of oscillation of this hacksaw blade? How to find the period? 10 oscillation is 5 seconds. So for one oscillation, how to find? 10 divided by 10 divided by 5 or 5 divided by 10, which one? So you it is 0.5. 5. Okay, 5 divided by 10. Ongja, you did it wrongly. Okay. 5 seconds is a total time for 10 oscillation. So to get one oscillation, where it will give you the period of 5 divided by 10, so it will be 0.5. Okay, 0.5 seconds. Okay, so you did very good. Alright. So this is how to find period. Again, what is period, students? Time taken for one complete oscillation. Okay, and then now when we find the period, now we can look for frequency. Okay, if you read from my screen, what does frequency refers to? Okay, frequency is number of complete oscillation made in 1 second. Okay, you write there, where is frequency? Okay, number of complete oscillation made in 1 second. You write the definition for frequency. And this is the symbol for frequency, F. And we measure frequency in a unit of hertz. Hertz. The symbol is Hz. Hertz mean per second. Okay, per second, number of complete oscillation in 1 second. So by using the same example, so later we can find the period. Where period is the formula, you can check there from your workbook. The formula for period is determined from F equal 1 over T. Okay, frequency F equal to 1 over period. Okay, 1 over T. So if the period now 0.5, so what will be the frequency, students? For the previous example, just now we calculate the period is 0.5, right? So what is the frequency? Yes, frequency is 2 Hertz. Yes, very good. Okay, so now let us check on amplitude. Okay, the third characteristic, amplitude. So what is amplitude refers to? Amplitude is the maximum displacement. Okay, yeah, just now you're counting frequency actually. All right. So amplitude is maximum displacement of a particle from equilibrium position. Okay, this is amplitude. Okay, so the center line is called as the equilibrium position before the system vibrating. Okay, the wave is in the equilibrium position. Once it started oscillate or vibrating, so you can see it will form a crest and a trough. So the maximum displacement of the crest or the maximum displacement of the trough from the equilibrium position considered as amplitude. Okay, again, what is amplitude? Maximum displacement of a particle from equilibrium position. Okay, maximum displacement from equilibrium position. And amplitude, the symbol is A. Okay, A. Sebenarnya dia capital A. But some books, they are using small a. Okay, and we measure amplitude in a unit of, what do you think the unit for amplitude? Displacement. What is the unit for displacement? We learn in chapter 1, chapter 2, chapter 1, sorry. Displacement. What is the unit for displacement? SI unit for displacement. Meter. Yes. Small m. Okay, small m, meter. Okay. And then period. Okay, period tadi cikgu sudah bincang. Time taken for one complete oscillation. Frequency, number of complete oscillation in 1 second. Okay, so period and frequency is related to one and another. Where to find period, to find frequency is 1 over period. Okay, and vice versa. Okay, then we have wavelength. Okay, any idea what wavelength refers to? Wavelength. Anyone? Wavelength. Okay, if you see from this diagram, okay, this is wavelength, lambda. Okay, lambda. So what shows here? Okay, lambda, the length from crest 1 to crest 2, Kappai said. Okay, very good, Kappai. It is the distance between two consecutive crests. Or you can say it is the distance between two consecutive troughs. If you are talking on transverse wave. And if you are talking on longitudinal wave, wavelength represented by distance between two consecutive compression region, or distance between two consecutive rarefaction region. Okay, that is wavelength. Or in general, we can say distance between two consecutive points which are in phase. Okay, the word in phase here refers to either two successive crests or two successive troughs or two compression region or two rarefaction region. Consecutive means one after another. Okay, the first crest to the second crest to the third crest. Okay, first trough to the second trough to the third trough. first compression to the second compression, first rarefaction to the second rarefaction. That is what we call as in phase. So are you clear now? Wavelength again is a distance between two consecutive points in phase, okay, which are in phase. And the symbol for wavelength is lambda. Okay, I missed the symbol here. Wavelength, the symbol is lambda. And the SI unit is, what is the SI unit? So wavelength is a distance. So the SI unit is meter. Okay, meter. Okay, then how about wave speed? Okay, this is the fifth characteristic, wave speed. What is wave speed? It is distance traveled per second by a wave profile. Okay, distance travel per second. You jawab sampai sini pun sudah cukup. Distance travel per second. And speed represented by V. Okay, so what is the SI unit for speed, students? What is the SI unit for speed?
Meter per second.
Yeah, come again.
Meter per second.
Yeah, very good. It is meter per second. Okay, this is the SI unit. We measure speed in a unit of meter per second. And this is the formula how to find speed of wave. It is F lambda. Okay, speed is frequency multiply wavelength. Okay, so you must remember this formula. Speed of wave represented by the frequency of the wave multiply with its wavelength. Okay. So these are all 5 characteristics of wave which you must understand and know each of them very well together with the symbol and appropriate unit. Okay. Any questions so far? Okay, example of characteristic wave. Okay, on top we have transverse wave. Okay, X1, X2, X3, X4, this is all the crest. Okay, while Z1, Z2, and Z3, this is all the trough. Okay, yeah, Sinwei, anything? How to know? How to know there? Can you just open your mic and talk? How to know what? Oh, my mic can, okay, you just start then. Okay, how to know what? Okay, well, down here it shows longitudinal wave. So P1, P2, P3, P4, this is the compression region. Okay, and Q1, Q2, Q3 is the rarefaction or the stretch region. Okay, so you can count lambda from P1 to P2, it represents lambda. Or from P2 to P3, it represents lambda. Or from P3 to P4, it represents lambda. Okay, and between Q1 and Q2 is also considered as lambda. Q2 to Q3 is also considered as lambda. I mean how they observe and draw the graph. Which graph? This one. Okay, from the movement. Okay, from the movement of the particle. Okay, for example, in the ripple tank, when you see the image form from the ripple tank, okay, so you can sketch the graph. So the ripple tank, it vibrates up and down. The water, when you vibrate a water, it vibrates up and down. Okay, remember I show you the simulation just now. We place a leaf, okay, and then we on the vibrator. The leaf represents the particle of the water. So we can see that the leaf move up and down, okay, while the water propagate outwards. So from there we can sketch a graph. Up and down show transverse wave, back and forth show longitudinal wave. Okay. Okay, class, now let's check on these exercises. For those who print out this module, you can check and mark and label the wavelength. So where we can mark and label the wavelength here. Above is transverse wave and below is longitudinal wave. So this is the first point you can mark. Okay, ini consider as lambda. While this one, this is the first compression point, this is the second compression point, this is also considered as wavelength. Where else can we mark? The wave not always constant, right? What do you mean not constant? Okay, the frequency is constant, so they are moving constantly. Okay, if the medium does not change. All right. Okay, then this is another part where you can mark the wavelength at. Okay, this is the first rarefaction region, and this is the second rarefaction region, considered as lambda. And this is also from the first trough to the second trough, also considered as one wavelength. And there is another part, okay, this is also considered as one wavelength. We have one complete wave here. Okay, this wave consists of one crest and one trough. So it is also considered as wavelength. Okay. Okay, and for second exercise, okay, can you count what is the wavelength shows in this diagram? Okay, from this end to the other end, it gives you the length of 20 cm. Okay, student, can you tell me what is the wavelength shows here? How to find the wavelength here? So first and foremost, you have to mark where is the wavelength. Wavelength dia di mana? From the first wavefront to the second. Okay, ini considered as wavelength. So how many wavelength you can see that? How many? Yeah, 20 divided by 5. So very good. You can see there are 5 wavelength, 5 lambda. This is the first lambda and this is the second lambda. Okay, ini lambda 1, this is the second lambda. And this is the third lambda. Okay, this is the fourth lambda. And this is the fifth lambda. So we have 5 lambda. So the total length is 20, which means for 1 lambda is 4 centimeter. Easy, right? Okay. Okay, then next. Okay, number 3. Okay, what can you say about this? It shows the wave profile. So this is the wave profile. You can see there is a crest and there is a trough. Propagate in sea water. So what kind of wave you can see here? Transverse or longitudinal wave, students? This is transverse wave. Okay, water wave is a transverse wave. It consists of crest and a trough. Okay, it says that propagates starting from point A. So this is the sources where the wave is produced. So you have to label the distance represent the wavelength. So which distance can represent the wavelength from where to where? Actually, you can write more than one answer here. So which distance represent the wavelength? C to E. Are you sure? Sin wavelength. Okay, how about the rest? Which distance represent the wavelength? AG. AG?
B to F.
Yeah?
B to F.
B to F. Yeah, B to F. One. Any more? Any more you can see? First is BF. Okay, B to F consider as the wavelength from one crest to another. Okay, ini wavelength. Where else can we write the wavelength? DG. DG. Okay, DG. Betul ke DG?
How about
DG
A
or
to E?
CG? Second, we have AE. Okay,
And
AE.
CG.
AE. And then we have CG. Actually, it's CG. It's in way CG. Okay. It consists of one trough and one crest. So there are 2 answers there. AE and then BF and then we have CG. Okay, never mind, you are learning. So now you're clear how to look where the wavelength is at. Okay, now pair of points in the same phase. So which point are in the same phase? Okay, we erase this first. Which point are in the same phase? Okay, any idea? AC. Same phase. Okay. Are you sure AC in same phase? ACA is like this, and then C is this way.
Oh, B and F.
Yeah. First,
B and
yes,
F.
B and F. B and F are both rest. Yes. Okay, so first B
Can we
and F.
consider
Any
D2?
more? A?
D. Is it
Yes, AE. Okay, AE. AE. Okay, AE. Any more? We have CG. Okay, CG. So these two are in same state. So we have AE, and then we have BF, and then we have CG. All right. Direction of propagation of the wave. So where is the wave? In which direction the wave move to? From here it says starting from point A, right? Starting from point A. So starting from point A means the wave propagate to the
right?
right or to the left? To the right, okay? Left to right. This is the direction of propagation. From left to right or from A to G. Okay, you can say from A to G or from left to right. This is the direction of propagation. Okay. Okay, now you have to find this amplitude, period, frequency. Okay, I think this is our last exercises before we end this lesson. Okay, in a short while, you are given a diagram show still, meter rule, clamp on a table. Okay, so this is the equilibrium position, okay, at the center. And it oscillates through A, B, C, B, A. So first it moved to A, B, C, B, and then went back to A. A, B, C, B, A. Okay. For making 10 complete oscillation is 8 seconds. Okay. For 10 oscillation, it requires 8 seconds. Okay. And given distance of AC is 12 centimeters. So what is the amplitude, students? Amplitude, remember maximum displacement from equilibrium position. So what is the amplitude here? So this is the where is the equilibrium position? This is the equilibrium position. So where is the amplitude? Either this or this one. Okay, so what is the amplitude?
6 meter, is it?
Yes, it is 6 centimeter. Okay, 6 centimeter is the amplitude. Okay, how about the period? Period. It makes 10 complete oscillation in 8 seconds. So what is the period? Similar
0.8.
similar to the word clock. So what is it? The period is
Divided by
0.8. Okay, F divided by 10. So for one oscillation is 0.8 seconds. Now how about the frequency?
the reciprocal of 0.8.
Okay, yeah, the frequency is the reciprocal of the period. So 1 over period reciprocal. So 1 over 0.8. So it will give you 1.25 hertz. Okay, 1.25 hertz. Okay, so this one, we leave it for tomorrow. So now what I want you to do, I want you to try to do exercises on page 1 to 5 in your workbook. Question number 1, graph of wave motion. Instead, the information can be obtained. And then you try to solve 1 to 6. Okay, 1 to 6 and 1 to 7. Okay, try 1 to 6 and 1 to 7 as well. Uji Kendiri 5.1. Okay, the answer we are going to discuss tomorrow. Okay, can you do them? Can you try to do them? Okay, everyone, please give a try to the exercises on page 1 to 5, 1 to 6, and 1 to 7. Okay, so I think that's all for today. Thank you very much for your presence. Thank you very much for your attention. I really appreciate you here. Okay, so any problem, you can ask tomorrow and we try to discuss all the favorable answer. Okay, so that's all for today. Again, thank you very much and have a pleasant day, everyone. Bye-bye. See you again tomorrow. Yeah, purple book, the workbook, 1 to 5 until 1 to 7. Okay, bye-bye for now. See you tomorrow at 11 past 30 a.m. Okay, thank you everyone.
Bye-bye. Thank you, teacher.
Okay, bye-bye. Thanks to you too.